So okay guys, it is another one, continuation from where we stopped. Electrochemistry focus video. We ended to the second aspect, 10.02. And this 10.02 basically I'm going to be talking about the Nernst equation, and the proposition of this equation was given by a chemist, a physicist, which gave a particular formula. So this is more like your aspect of physics and a little bit of math on how to calculate the E.m.f. that is flowing through an electrochemical cell. In 10.01 we have discussed some example with respect to how to calculate the standard E.m.f. for a half cell and for a full cell. We talked about electrochemistry in terms of, please just listen, this is self-explanatory. I'm not going to write anything. Like I said, all these videos are taking time to produce, but the fact is, even with you just listening, you can go along with them and solve them on your own, because they are detailed and straightforward. So having said that, I'm not going to waste time. 20-25 minutes is what I'm going to use. Just a 19 slide I've presented in this video slide, which I'm going to talk extensively on the Nernst equation, which is basically on formula. So on formula-based questions, you expect questions 1 or 2 for your A-level chemistry, or those of you that you are into chemistry in the universities. So just try as much as listen to how the application is being done and how to use the formula. So let's talk about the formula itself. Next page. Now, this is the formula we call the Nernst equation formula, and it was just a kind of relationship that shows how to calculate the general E.m.f. flowing through a battery or a cell, as you call it, when you know the standard E.m.f. by using the formula we talked about in 10.01. That is the formula that says the E right minus E left, E cathode minus its E anode, when it is in the reduction form. Remember, the more positive, the more reduction form. That is all what we talked about in the last lesson. So using this formula, the formula just tells us about the standard E.m.f. of a cell minus 0.0592 divided by the numbers of mole multiplied by log of Q, where Q is taken to be either concentration of the of the battery or the partial pressure of the battery. Now, there are other things we are going to discuss as we proceed under this formula, because this Q, when the Q is constant, we said the system is at equilibrium, which is another topic we've talked about on this page. If you are new to us, you can consider subscribing. So be careful about understanding the concept when this guy is at equilibrium. When this is at equilibrium, when Q is equals to what? When Q is K, that is K we call equilibrium constant, we say the total E.m.f. that is flowing through a battery, the battery is dead. So when you say battery is dead, you know what it means. It simply means the E of the cell is equals to 0. At that time, you can only calculate the standard electromotive force that is flowing through the cell. So be careful about it. This is standard electromotive force. This is the overall electromotive force flowing through the circuit. So this man, how does it come about this formula? But the important part of this thing is just for you, dear students, to know how to apply this formula. It is quite important you know how to apply this formula we are talking about. This particular formula you have to memorize. And how does it come about? It at standard condition. We've talked about that time and time again at standard condition. How it comes about 0.05. We can talk about the mathematical relationship. Be careful about cell potential is E, then E naught is standard potential. Then we talk about N as number of moles, whereby log Q is given as, we're still going to talk about it very well. It's always given a concentration of product raised by the stoichiometric constant divided by concentration of reactant raised by what? Stoichiometric. That is concentration of partial pressure. So all this we are going to talk about. But before then, we're going to talk about how it comes about this formula. Let us look at the mathematical derivation of this formula. Let's see that. Now, yes, we can move. This is it. Fine. This is what I'm talking about. Now, Nernst equation can be used to calculate the E of cell for any chosen concentration. Now, how you come about it? Say E of cell is the standard E.m.f. of a cell. That is minus RT over NF, ln of concentration, active mass of product concentration divided by that of reactants, as I've said. Now, substituting the parameter, we know molar gas constant is R. It is 8.314 for standard what? And at room temperature, it is 298 Kelvin, as you can see. Substituting this, we have 0.0257 divided by number of moles. 2.03 log means log of a particular number to the base of E. Don't worry about your mathematical ability if you are not so good. The final formula is just what you need. I'm just showing you how we come about that. Log of product over reactant. So going by this, multiplying this by this, we now have next page there admin for you to see the final formula. Then if we go by that, now we now have E of cell is now equals to, where I'm going, is equals to standard electromotive force of cell minus 0.0592 divided by numbers of mole. Then you have log of Q, where Q is also what you need to keep in mind. Because if you are just training this course on the second part, you may need to go through the first part when we talk on how to get this one, because you need to know how to get this one. This is what we talked about in the last part. So that means you can move to the next one. Now, first example I'm going to do, I said it is self-explanatory and I'm not going to waste your time on this. Now, the first example I'm doing is you have to consider the electrochemical reaction. Zinc is solid. You know what it means. Because it is solid, it's going to be at the anode. We've talked about that. Then nickel 2 plus is in the aqueous solution. That's the reduction part. You know that. Then it forms solid. So the first thing you do, because the question asks you that the standard cell potential E0 is 0.51 volt. Find the cell potential E of the cell if the N12 plus concentration is 5 moles and the zinc 2 plus concentration is, this is a direct formula based question. You know the formula is saying E of the cell equals to the standard electromotive force of the cell minus 0.0592 divided by the numbers of mole, then log of Q, where Q is the concentration of the product divided by the concentration of the reactant. So I think it is straightforward. But before you do that, you have to write the standard half cell equation for these two. That is, write the anode equation and the cathode, then combine them with a short bridge equation to get the number of mole. But I haven't said that even if you are those that are used to my classes online, the number of mole, because this thing is 2, this thing is 2. One is reducing, oxidation takes place at the anode, reduction takes place at the cathode. So the number of mole is 2, as you can see from here. So, but for you to see that mathematically and stepwise, let's see the solution to this. Now, solution, display the solution at me. Thank you. Now, the first part is, we write the reduction. I told you, aqueous will always be the reduction. The more positive, the more the reduction ability. I have said that. So Al3 plus is more what of the reduction form than what Zn2 plus. That is just the logic. Now, aqueous solution, you can see reduction means loss of electron, gain of electron, plus 2E minus to give you that. Plus now decrease in oxidation number from 2 to 0, as you can see. Then you write for the oxidation part of the half cell, which is solid to aqueous. Zinc was from 0 here to 2. This was discussed in the last class. And I told you, then 2 we cancel out 2. It is self-explanatory. Then combine the equation. You can start from Zn solid plus this one, that is the left-hand side. Then you come to the right-hand side to have Zn2 plus aqueous plus Ni solid. So we are given in the equation, this is given standard electromotive force of the cell is given to be 0.51. Now, the Q that I told you about, the concentration, that is of the product. You know, everybody knows that word. The product is always what? Anode. Let me let you know that. That's why the reactant will be the cathode. As you can see now, this is what we call the product, Zn2 plus and Ni2 plus. So this is the reactant and this is the product. So you just substitute those values. We are given the value 0.05 and 5. So using the formula of the NERNST equation, which is where I'm going, you can see from the third step here, we have E of cell is standard E.m.f minus 0.0592 over N. So N is what I need to let you know. N is what you can see at the beginning of this thing, it is 0, at the end it is 2. So N is what is 2 moles, as you can see. So substituting this in the formula, this is a formula-based direct question. Substituting and punching your calculator, this was given 0.051 minus this divided by numbers of moles are 2, log of this concentration of the product. Product is always the what? The anode. That's another way to just know that product over that of reactant. You understand? Product side is always this one. This is the aqueous solution and this is the reactant. So consider the aqueous solution of the two. Please note that because you are dipping them in the solution of that. So doing that and pressing your calculator, final answer is just going to be. Remember that you can press log For those of you who don't know how to press calculator, log of this first, then you multiply by this, then you subtract your answer from this. You have to do what is inside the bracket first before you talk about any other thing from your knowledge of mathematics. So admit please, this is just a simple question, which I believe this is self-explanatory, nothing to talk about the next. Now, we take another example, and in this example, we are going to make it a kind of a cell that is combined with what we call a standard hydrogen electrode. Let's see how to calculate the value of the N, or in this case, we might try to shift the condition and ask you to look for the standard E.m.f. of the cell, whereas we give you the E.m.f. of the cell. You understand? Just changing the position of questions and see how you guys can solve questions mathematically. So you also expect this. Now look at this now. Electrochemical cell is represented as platinum. You can see inert electrode. Platinum is solid, was dipped into what? You can see this is what we are talking about. Platinum dipped into what? H2 hydrogen. Then you can see this is the focus on this. That is what, if you follow the first stuff, we've talked about this. Then it was now mad. This is salt bridge. I'm not going into details about this one because we are just doing the next equation. Then the air was deep, was now mad with what? This one, as you can see. So at 1 molarity standard condition, we've talked about standard hydrogen electrode in the last class. But that is not even what we are after. What we are particularly about is the question. If the value of the cell potential, you can see the cell potential was given. That means E is given. So determine the concentration of H plus. You can see we are looking at concentration of hydrogen A. I like this question. You can see standard hydrogen electrode is always 0. You know that. So you can see it's given to be 0. And from what? From silver solution to silver, 0.80. What is the formula? E right minus E left to get our standard E naught. So what we are going to do in the next page, admin, please show us that. Thank you very much. To first write the equation, overall cell equation of that thing. Remember, we are going to go to the previous. Admin, please go to the previous for them to see what I'm writing. We have to get the reduction and get the what? Oxidation. Now, definitely no doubt about that. The more positive, the more the reduction. I've talked about that. This guy is reducing, and previous, the next page. Now you can see Ag plus is losing 2 electrons to give us 2 Ags. Then the oxidation is hydrogen. Hydrogen gas. Previous, please, for them to see. Previous, thank you very much, admin. Hydrogen gas, you can see this is hydrogen giving you what? This particular A when it was deep in solution. So please, next. So hydrogen gas now gain 2 electrons. You can see what I told you. This is like this. Then combine the reaction. Write the left side. That is this and this. You can see the left side. Then the right hand side after you've cancelled the what. Then how to write this type of equation, we discussed it in the previous slide. So this is the overall cell equation which we need. And like I said, this for me sometimes, like I do test students, it's just for you to be able to follow all right or fulfill all righteousness. If you don't want to write that, I think it's quite easy sometimes to get how to do that. So we need to get the standard E.m.f. of the cell. E cathode minus E and E right minus E left. So the right hand side of the equation, that's reduction minus oxidation. The more positive, the more the something. Like I tell you, the anode is standard hydrogen electrode. You understand? Standard hydrogen electrode is 0, as you can see from the oxidation part. It's always having 0 volt. It was given. Admit please, previous slide for better understand. You can see she is 0 volt, whereby for silver that's on to the other one, it is 0. So the standard will be what? E cathode minus E anode. So we subtract more reduction minus oxidation, more positive, more reduction. That's what I told you. So to get the standard E.m.f. of the cell, it's just this minus this. Please, and I told you the number of moles does not have effect on the standard E.m.f. of the cell, so we don't consider 2 moles or whatever. So we subtract this from this, and by and large we have this answer. So using the formula of Nernst equation that says E of cell equals to standard electromotive of cell minus 0.0592 over n log of H. Now, this is where something is. We have to write the value of this one because it is very important we understand this. Because if we don't get that, then we're going to suffer a little bit, which I don't want us to have any issues with that. We are not going to suffer anything if you listen to concept well. So look at these guys. Now, the number of moles is crystal clear. We know how to get the number of moles of the aqueous solution of this and that of that. So doing that, you can say this is 2, as you can see, and the guy here is also, you can see, that's 2, n is equals to 2, done. So this is what you are looking for in this question. You are not looking for any of this and this. This was given to be 1.98, previous one. We subtract this from this to get 0. This. So this is a constant value from the formula divided by 2. Then log of, I hope you are following, because this is where it matters. Now, log of, this is where we are going now, because we want to calculate the concentration. The question asks for concentration of hydrogen ion, and you know Q is given as a concentration. So be careful about that. It's always concentration of product over reactant. That of product divided by reactant. So in this question, I told you the product is always the what? The anode, whereby the reactant is always the cathode. That's just the logic. So she H plus raised to power 2. How did I get H plus raised to power 2? Look at this. You must have the knowledge of equilibrium constant. You can see the stoichiometric coefficient here. We come to the top. I hope you still remember that from your knowledge of equilibrium constant. And about this reactant, you can see is Ag plus, then this stoichiometric constant will also come forward here, multiplied by, now, pH2. Now, pH2 is just what I call, for here, I call it what is the platinum electrode that was used, so, which is taken to be 1. It's not that. Then the question asks you to get the 1 of hydrogen here. So it is just a kind of calculator stuff, like I do say. This is calculator-based question. You get this, given this one, E right minus E left. This is true from your equation. Then you are looking for concentration of hydrogen here. What you do is just finish this. You have to do the bracket first, like I do say, because this is where something needs to come in. Now, always keep it in mind. H plus from here, if you do your mathematics from here, H plus will give you this value of 1.9 times 10 raised to the power minus 7. So, but the question asks you to calculate, if the question asks you to calculate the pH of the solution, you know pH equals to negative log power of hydrogen to base 10. So, but the question, I think the question asks for H plus, that is the concentration of hydrogen. So directly just make this subject of formula. And if you are still having difficulties with that, I can help you do that without wasting time. But because of time frame, we move to the next one. Thank you. Now, going back to a quick revision on what we studied the other time. Now we talked about the impact or the applications or some of the applications of the E.m.f. of a cell and how we can use it to calculate the spontaneity of a reaction. We said that if E.m.f. of a cell is positive, that means the reaction is what? Is spontaneous. If it is negative, it is what? Non-spontaneous. If it is equals to 0, it is at what? Equilibrium. So this particular thing also link with your equilibrium. So the linkage is what we are trying to let you know conceptually. It's not just about knowing the formula, knowing how the application comes about, and these are our aim of taking you through with this simple thing that is crystal clear and visible to everybody to see and understand. So haven't have this idea. It is now possible for the battery or for the reaction to be at equilibrium. If the reaction of the whole cell reaction is at equilibrium, we said the E.m.f. flowing through the cell is equals to 0. So remember the next equation says E flowing through the cell equals to the standard E.m.f. of the cell minus 0.0593, 592, 593 divided by the numbers of log of Q, where Q is like the quotient of the what? Product over the reactant. But in this case, when E flowing through the cell is equals to 0, that is when the cell is at equilibrium, what we need to think about is that means what? The value of what? Log K. Log that particular Q, which is quotient, is also going to be at equilibrium. So what we count on, we change the value of the Q in the formula of Nernst equation to K, where K stands for the what? The equilibrium constant. So just keep it in mind, when there is no E.m.f. flowing through the cell, we said that cell is at equilibrium. So admit please the next page to talk more about this. Now look at this now. This is where we are going. Before then, I think we have an example. Which of the following reaction can occur spontaneously at 25 degrees Celsius? You know that is the room temperature. If Fe2 plus has a concentration of 0.60 molarity and Candium 2 plus has 0.010 molarity. We have to write the equation. I think the equation was even given. See here, we are given the potential difference of what? The standard potential difference of each of them. Then I told you the more the positive ion, the more the reduction value. So you should just know, just if you know one, you know the other. What am I saying? Just compare this. I hope you know the value of negativity. So the more the positive, the more the what? That is, which one is more which one is higher between minus, just like which one is higher between -1 and -2. You know -1 is higher than -2. I hope you guys have an elementary basic knowledge of mathematics. So all these are also applicable. And again, if you go by the equation of reaction, it's so simple to also see some stuff. If you watch very well, so let's just quickly do some stuff for you to see what I'm talking about. If you watch very well, this is aqueous and this is solid. So it goes without saying, you know what should be your anode and what should be your cathode. So I don't think this one. So we get the E.m.f of the cell by saying E cathode minus E anode. Do you understand? E cathode minus E anode. So when you do that, how will you know the cathode and the anode? I told you by writing the full equation. If you want to write, even by knowing the one that is solid will definitely be at the anode, and the one that is in aqueous already will be the cathode. These are terminologies or start we've talked about in the first slide. Next slide. So I will continue with the calculation. So writing the full reduction, you can say reduction will be this, and whereby this guy will be the oxidation. I told you, because according to the question, this is the solid form. The solid form was deep in solution. That one we oxidize. Whereby this one that is already in solution we reduced. That is the logic we are using. So following that, writing the equation, the same method, same way. So calculate the standard E.m.f for E cathode minus E anode. Now you know the cathode, you know the anode. Subtract the 0. Another way, the more positive will be the cathode. That's that. Now from here, 0.44 and 0.4, like what I said, -1 is bigger than -2. I hope you know -3. -2 is bigger than -, you are coming -3, -2, -1 is 0, 1, 2. So if I ask you simple mathematics, I hope you guys are following. Which one is bigger between the 0.40 and the 0.44? So what we are saying is that 0.40 should be bigger than 0.44. Do you get that? Because as you are coming like this, as you are coming, the number is increasing from left to right. So that's just the logic. So E cathode minus, so we have minus 0.44 as the cathode given, minus that of the anode, 0.40. So when we do mathematics, we can say this is going to give us, this mathematical way is going to give us this minus times minus is plus. Then from calculator, we have gotten the amount of standard E.m.f flowing through the cell. Don't forget Nernst equation. This is E0. You understand? E equals to E0 minus. So please, next slide for you to see. Now, the interpretation of this is for you to place. Okay, no problem. I think I should be able to do that. So going by continuation to get the value of our number of mole from this reaction, you know how to get number of mole. The number of mole that is true. Then again, here, Q means, we've talked about that, the concentration of the product. What is the product? CD is the product. The anode is always the product. The cathode is always the reactant. The product is always the anode and the what? And again, you can get it from here. See, this one aqueous form over this one. So the concentration are given, and these are the value of the concentration according to the question. So we divide this by this, we get the concentration. Please move to the next slide. Like I said, they are self-explanatory. So using Nernst equation now, substituting all those values, this is just like what we've done. And the first example, we got this one from our calculation, minus this is a constant, number of mole is 2. We are given the Q of the product over that of reactant. Punch the answer, E flowing to the cell is this guy. So if E is that, what we are trying to say here, dear student, is that we don't need to disturb ourselves. If the answer to this is this, so this particular value, just like the first chapter, can help us know if the reaction is spontaneous. This is a positive value, and what it indicates means what the reaction is, of course, naturally, because it is a spontaneous reaction. So like I said, it's a very simple slide, which we are not disturbing ourselves. We are only focusing on how to use the Nernst equation, which is this equation, to get what the value of answer. Then we want to also talk about when this is at equilibrium. I said Q will be equals to K for equilibrium, and another point is what the E of cell will be equals to 0. So these are just two things that I want to add to the Nernst equation, and we are going to see example in the next slide. Thank you. Now, when there is no Nernst equation, that means Q is equals to K, or when what the E of cell is 0. So when you have a dead battery, it occurs when the system reaches equilibrium or no more free energy. The free energy is given as delta G still talk about that as we move forward. What is it? There is no more work on the word. So this is the full formula. Q turns to K, and this guy is equals to 0. On that, we can just say application of the formula is this, because when this equals to 0, what happened? You know what happened? This gets moved to this side, to be negative. Negative cancel negative. That's where the negative is no more fun. Please be careful. If you just know this formula is okay. So when they now say the reaction is at equilibrium, just know that what two conditions, there is no E.m.f. in the cell, is equals to 0. Then the value of Q is now what constant equilibrium constant. Next page, last example. I'm going to do example for the calculate K for the zinc copper cell. So we have E of the cell, you can see standard E.m.f. of the cell. We know the formula NERNST. We just calculate that. The more positive, the more. I love this question. Now, this will be the cathode, this will be the anode. The more possible, the more the reduction ability. So that's just that to get that. Next, agree. So now here we can now say the answer. Write the full equation. Now this will be copper giving you this. Then this one also, because according to the, it must always be in the reduction form giving you this. So reduction form is why did I know that this one will be the reduction, this one will be the oxidation? Because of the value of their this. See, more positive cathode, that is more reduction. More negative, more oxidation. So that is why I know, because this is more positive, so it will be what? It will be the reduction equation. Please note that. So writing that the normal way, we've talked about this given in the question. So we write this is the overall cell equation. And if that is the overall cell equation, permit me to claim. If that is the overall cell equation, so what we're saying is that if that is the overall cell equation, so what we're saying here is that the formula for standard E.m.f. of a cell is E cathode. So E cathode minus, even if I didn't write the equation, like I said, I can quickly apply the formula here, get the value of, need to get the value of this, and get the answer to the E that is flowing through the cell. The standard E.m.f. of the cell is plus 1.10. But remember, the question asks us to find the nature of the what? The cell. Is it spontaneous? It is at equilibrium, or so on and so forth. Then admin will take us to the last slide to see this. I think we have one more slide. Yes. Now to now get the final answer. Now that we have that, which is the last slide I'm talking, we now use Nernst equation. This is Nernst equation. Remember, this is equals to 0. So substituting that directly 0. This was what we got by saying E cathode minus E anode minus 0.952 or 0.592 divided by 2 log of Q is equals to K. Please don't make mistake about that. So now it is this K that we need according to the question. So what we do is just doing our mathematics. So making log K, so the formula it will be this multiplied by 2 divided by this. So on substitution, we have log K is equals to 37.162. So how will you get K? K will now be taking natural log of both sides. So when you place natural log of 37.162, you are going to get 1.5 times 10 raised to power 37. So be careful. We can use the value of Nernst equation to calculate equilibrium constant when the cell battery is dead and when there is no work on the battery. So be careful about this. The Nernst equation is very, very applicable, and in most of the exam you can be tested on how to use this. Be careful to know how to write the full and the half cell equation, and also to calculate your number of mole as well as concentration. I'll see you soon in 10.03, where we are going to be focusing on electrolysis and some factors that affect electrolysis and some electrochemical series. I'll see you soon, guys. Don't forget also to subscribe, like, share, and on the notification button. Take care of yourself and you have a wonderful time. Bye for now.